the Microsoft Learn Student Ambassadors Program, if you didn't know. And this will be recorded in its entirety and will be available for future reference. So drop a emoji in the chat if you are joining in. It will just let me know that you all are active. So we will begin then. If you are new to Teams, you can find on the top bar, you can see show participants and show conversation. You can click on show conversation and then you can get access to the meeting chat. Just drop a hi or an emoji to let me know you can access the chat. Great. I am seeing some emojis. Great. Okay, I'm really excited for today's webinar only because the topic is really exciting. And one quick thing, everyone who has registered for the event, they will be receiving a certificate at the end of it, and most probably by tonight. So if you have any questions at any point, type them out in the chat window, or like you can also unmute yourself at the end of the session. So I can then take up your questions at that time. And I'll try to take up as many questions as I can. Okay, so before we begin, you can also take some screenshots and post it on your socials. That will really help me a bit. So that is there. So, okay, let's begin. So, good morning, afternoon, evening, wherever you are joining from. Hope everyone is doing well. And today we will be taking a look at how we can leverage the Microsoft Azure platform and like use the Azure Machine Learning Designer to create all these powerful machine learning models that you have been hearing of, and then like deploy them at a service like as a web service, so that you can use a browser to connect to any of these services and like get some forecasts and predictions out of that machine learning model. So the title is Create and Deploy Machine Learning Models with Azure Machine Learning Designer, and let's dive right in. First, we will be talking about like how does a machine learning project look like on like a larger scale. So and like on a larger level, what does it comprise of? So before learning about machine learning projects, we first have to just have an idea about what is machine learning. And it does not have like a well-defined definition, but like some people have tried to give it a definition. So Arthur Samuel, as you can see, they have said that it is a field of study that gives the computers the ability to learn without being explicitly programmed. So that means that we can have data and we can create models out of that, mathematical models, obviously, and that will help a computer to quote unquote learn without any instruction that is given explicitly. So that Tom Michel then defines as what is learning. Then I said that machines can learn and can do machine learning, but what is the learning process here? A computer program that we will be creating is said to learn from a certain experience if it can do some certain tasks that is denoted by T in their definition, and we can get some performance measures like metrics, like accuracies and stuff like that. And if those seem to improve with time, we can say yes, our machine learning model is learning. So that is my definition of learning, that as you are getting all of this experience by seeing the data or like performing any tasks just like a human being would with practice, as you gain experience, your accuracy gets better over time. So that is the definition of learning, and that is what we are trying to teach a machine to do without coding it out. So that was machine learning. And how do we apply machine learning? Like there are three major techniques to apply machine learning, and that is not an exhaustive list. There are other ways as well. So first, we will just try to take a look at what is on the plate here. So we have supervised learning, obviously, and unsupervised learning and reinforcement learning. Many of you must have heard about some of these terms. Many might have not. So just let me give an overview of each one of these. So like in supervised learning, you have certain algorithms and like you have the data itself. First of all, like you have the, you know what the output will be, and like using that, as you can see, the data will act as a teacher. So we know how the data looks like, and we will train the machine to give an output that looks like that output. So that is supervised. We know what it looks like, and we know what the input is, and we know what the output should look like. That is supervised. Unsupervised, you don't know how the data looks like you want to find some pattern in the entire data, and like want to like classify it or something, and like derive insights that are not visible to the naked eye and stuff like that. There you use an unsupervised learning algorithm. Why? Because you are not sure like what you are looking for, so then the machine should tell you what to look for. So like that is the thing. Then there is reinforcement learning, and what happens in reinforcement learning is like if you have like a self driving car, and you want to make it learn like what is correct and what is incorrect, like without any human guidance, whether to cross a red light or whether to stop before a pedestrian. If you want the machine to take steps like that without your supervision, that would be reinforcement learning, because then it will try to do all the permutations. It can hit a pedestrian, it can run a red light, and then it will learn, it will get a penalty for each of those actions or a reward for doing something good. So that is reinforcement. It will get a feedback that whatever you did was good or bad. So that is how it works. You can also have something like a recommender system. So in recommender systems, what will happen is like if you have a customer who is constantly looking at different products, and you want something that is relevant to them, you can show them, or any TV series that might be relevant to them. So these are like some of the basic machine learning techniques that you can use, and you can implement machine learning in any way that you can, as I showed there. And what can machine learning do with all of these techniques and whatever we will be talking about for the next 1.5 hour? You can predict all the values. Like if you have a stock data of all the stock listings, if you want to like predict what will be the stock price after a certain amount of time, or like whether what will be the temperature tomorrow, by using trends and stuff like that, you can use machine learning to do all the predictions there. You can identify any faults that are there in the data, or like if it is like you can identify financial risks. You can identify like whether if there is any error, like typographical errors or spelling mistakes and stuff like that, that all of that comes under anomalies. So you can identify anomalies like that, or you can use it to find any type of structure, like this is a segment of customers who would like to buy a car or an automobile, and this is a set of customers that only like to buy and look at books. If you want to filter out people on that basis, like customers on that basis, you might not be able to do it in like a supervised way. Why? Because uh, a customer may buy many different types of products, but they have an inclination towards one thing or the other, and these are like patterns that are not trivial. You need some other agent to tell it to you. So machine learning can do that tasks as well, and also predict categories. So say that there are certain symptoms, and if you want to like say whether that person has certain disease or not, or like these are some of the features of a certain plant. So is what type of plant this is, or what type of flower this is, based on some image. And you can use machine learning to do that as well. So like that is very flexible, and all of this stuff machine learning can do, and this is again not an exhaustive list. It can do much more. And how does it do everything? It uses mathematical models, let us just say that. So there are different machine learning algorithms out there which use different types of mathematical models. There are a lot of equations, there is a lot of linear algebra out there. but we don't need to go into these right now. And you can obviously take out your leisure time and learn about each one of these algorithms. But like an overview, you can have linear regression models, you can have logistic regression models, naive bayes, support vector machines, decision trees, and like there is a lot of stuff: k nearest neighbors, k means, random forest, and gradient boosting, and stuff like that are all over the place. There are a hell lot of different algorithms that you can use, and we will not be going into the details and implementation details into each one of these. But how can we use these concepts to come at a solution? So as I was talking about, let us take a step back and look at the bigger picture out there. Like, how does a machine learning project work basically? What are the steps in that? First, you have to define the task, that what is the thing that I need? What is my business problem? And once you have that clear, rest of the things should be straightforward. Not easy, straightforward. First, you have to collect all the data. Like you can see, the first step is like explore and prepare the data. But for exploring and preparing the data, you also need data. So you have to collect the data from different data sources, and then you have to integrate and collect it out somewhere on any database or any file or something like that. So that is your data collection part. And also that data collection method that you use, that matters a lot at the end. Then we have to prepare the data and explore it. By exploring the data, you can see that what is wrong with the data, if there is something wrong with the data, like if there are any duplicate values or there are errors in the data, you can find that out while exploring. And then you can also explore, like, how can I represent the data in a much better way, that you can find out while you are exploring and playing around with the data. And then the preparation steps, as I was saying, that you can have duplicate values and missing values and stuff like that, and you can filter that out in that step. Next step will be the training and validation of a machine learning model stage, and that we will zoom into it in a bit. But like that is where the main machine learning training comes in. You have heard about the term training in machine learning, so that is where everything happens. Then we come to the stage where we deploy the model, and this deployment means making it in a format so that we can use it to do our job. What our business need was, we can use that model to do that stuff. So like that is the deploy model step right here. And the stuff does not end here. It is an iterative process, and it is really important to keep track of what things are happening. Why? Because there are certain sectors where machine learning is used and it is a high risk environment, like financial stuff. So you have to keep a track of when this machine learning model was created, who created it, and what was the data that was used to create that machine learning algorithm and stuff. So we have to keep a track of that so that there is no legal problem or ethical problem for that matter. So for that, we have MLOps, machine learning operations, that manage all the versions of every step that you do, and then also monitor it, like whether our it should identify, like, if our machine learning model is doing something wrong, it is giving wrong outputs, so we might have to fix that issue. So all of that is covered in machine learning operations. And Microsoft Azure makes it really easy to do all of these steps, and we will be taking a look at how. And as I said, we will be zooming in into the training and deploying and that training and validating model step. So the thing that happens is, like, you will get the data, but you do not pass on the entire data and let the model do everything with it. You have to first divide it into certain sets. And why this is important is because if you know that your machine learning algorithm can give a certain output for a certain set of input, and if you run it again and again on the same thing, you know what is going to be out there when you want the output. There will be nothing new in it. So for that, what we do is, like, split the data set into two parts. First, we will be calling the first part as the training set and the second part as the testing set, so that you can train the model that look, this is the structure of the input and this is the output that we are getting. We use that part of the data to get that behavior out of the model, and then whether it is doing it correctly or not, that we can evaluate using the other part of the data that we left out. So once we are happy with how it is behaving, then we can mark that model as a version, and then we can deploy it, and then we can obviously monitor it. And if there are certain improvements to be made to the model, then we can see that whether we need to make any adjustments to the data or not, so that we can train the model again and make it better, and so that we can get better predictions out of that. So like that is the model life cycle and the project life cycle. That it is a big picture of everything. So, one of the most pertinent questions right now will be like, why are we using Azure to do the machine learning? If you have researched a bit about that, you have many machine learning frameworks out there. You have TensorFlow, you have PyTorch, or you can also do machine learning within MATLAB as well. So, why should I go for Azure or anything or any competitor for that matter? So, we will be now getting into that. Microsoft Azure, if you do not know, it is like a cloud computing platform that is provided by Microsoft, and it is a public, private, and a hybrid cloud computing platform. So all of those different types are supported, and it has a pay-as-you-go model. So you do not pay for an entire subscription; you just pay for what you use. There are different cloud computing platforms provided by other competitors as well, like Amazon and Google and even IBM. So you can use those as well. But we will be for this session using Azure as our cloud computing platform. So using Azure, why do I pick Azure? Because you have all of the a massive global network of data centers. Like all of the other competitors also have that, but if you are using Microsoft technologies right now, it might make sense to stick with that and use the Microsoft managed data centers only to like do your machine learning as well. And contrary to what most people feel like that what happens in the cloud, we can just make different virtual machines, and instead of running it on our machine, it will just run on the cloud. No, it is not only limited to that. There is a lot more that goes on into the cloud. You can have virtual networking, you have storage, you have databases, you can have email services and notification services, like all of those push notifications that you get on your mobiles phone and stuff. All of that is powered by the cloud. So you have more than 100 services, and Azure provides you all of these services on its underlying the data center infrastructure. So you can have compute, you can have storage, you can have virtual routers, virtual switches, and stuff like that, and as well as new software things like security, and you can have data lakes, and you can use Xamarin to also create mobile applications and stuff inside the cloud. And even if you are fiddling with IoT, you also have those services inside Azure. There are multiple ways to work with Azure. First of all, you have this entire web platform, this web UI that will be the Azure portal. Then you also have a command line interface if you want, and that is the Azure CLI. And you also have a different REST API endpoint. So if you want to write a program to do certain tasks on Microsoft Azure for you, you can also have that. So that is also there. And yeah, so there are multiple ways to interact with Azure. Then this was Microsoft Azure. Then what is Microsoft Azure machine learning? So like compute, like storage, like all of those networking bits, you also have another service that helps you in doing machine learning and like implementing that entire life cycle of machine learning. And this is really important because there are many people on your team who will be working together on a project, and not all of them may have development experience, and but they might be very good at management. So we have to bring all of the machine learning operations to the entire team, so that not one person is responsible for everything. So for that we have to do collaboration. So that happens when you have an entire workspace or a workbench where you can work together. So Azure machine learning gives you that. Also, it gives you the entire the reliability and security of cloud, and along with that, the environment to run everything. You can obviously do it on your machine or your own servers, but then you lose out on some of those other bits. It is like end to end. You can start from exploring the data to deploying the model, training the model, and also then creating versions of the model and that stuff like that. So that is there. It is very open because you don't have to get stuck with Azure machine learning only. Like if you create a machine learning model inside Azure, you do not need to get stuck with like I will only use Azure from now on, or I cannot use my other machine learning models and I have to build up from scratch. No, that is not the case. You can, yeah, create Azure machine learning models inside Azure itself, but you can also bring your own. Like if you have used any of these machine learning frameworks, and if you are a developer, machine learning engineer, or if you have worked on those roles, so you might be knowing about scikit-learn, tensorflow, keras, mxnet, and mlflow, pytorch. So you can have your machine learning models from all of those different open source technologies and closed source technologies. And then you can also have different languages like Python, Erlang, and other languages. There are a few more languages also that are supported, and you can use any of the development tools to work with Azure machine learning. So you are not stuck with only one interface, and like you have to do everything in that. No, you have a lot of flexibility. And in case you don't want to create, like if you don't want to go into the entire life cycle, and you just want a simple way out, you can use Azure Cognitive Services. Like these are some of the services that are made for trivial use cases. So if you just want to take some decision, like if you want to do some content moderation, just like here, so like if you have a live stream going on and there are comments that are floating around in the live chat section, and if you want to detect like whether that is offensive or not and then report the user and stuff, you can do that with content moderator APIs directly. These are ready to go and pre-trained, so that you only need to use its services. You can use language APIs for like text analysis and translation and stuff. So whenever you use some translation service, it has machine learning at its backend. It may be pre-trained, it may be training on the go, who knows. Then you also have speech APIs, which can do that speech to text and text to speech, and also translate and recognize your speech. You also have vision. So one most common workflow is like you train the machine to learn to recognize some of the images, and then you predict that what type of image it is. So you don't have to do that from scratch because this is very trivial. So Azure Cognitive Services already has the functionality. You just need to use the endpoint and get going. If you just have to integrate it and not train the model from scratch. And all of the things that I just spoke about, like the collaborative workspace and all, where we can do everything machine learning, is this interface. This is the Azure Machine Learning Studio that you will be getting access to. This is where you can do everything, like create all the machine learning models and run automations and do all the things that you need to do for a machine learning project, from first step to the last step. You can do everything in within this UI, or you can use the CLI or the other the software packages to do the same as well. But we will be sticking with this graphical user interface so that it is easy for all of us. So in order to get to this workbench, we have to provision that. Like Azure has a lot of services that are floating around, but we have to get hold of one of them, that is the machine learning workspace. And how do we get a hold of that? So for first of all, you will need a Microsoft Azure like an account. You can sign up for a free account as well, but you will need to register a credit card, so that in case you use a paid service, then it does not cause any issues. So first thing, you have to go to this portal, that is portal.azure.com. Once you are signed into your account, and you will get access to this entire screen. And as you see that there are a lot of services like storage accounts and SQL databases, and then you have some other services as well. Those are listed on this sidebar. We will click on this create new resource to get ourselves a machine learning workspace so that we can do machine learning only in Azure. We don't need to do anything else. We only need to do machine learning. So for that, we will click on create resource, and I'll show you how we can do this. I'll switch out from my slides and also share my screen and show you how we can do this live. So once we click on create a resource, we will be greeted with this screen where we have to select like which type of resource do you need. Like, do you need a computer vision cognitive service, or do I need a virtual machine only and not do anything else, or do I need some machine learning tools? So I'll search for machine learning. If we have these handy categories on the side here, we will click on AI plus machine learning, and we will click on create right here so that we can create a machine learning resource within Azure portal. Once we have done that, we must understand what a machine learning workspace actually is. So when we create that machine learning resources, it will create a lot of things for us, and we have to understand what it will create for us. First of all, you will be seeing that there are a lot of services right here which are marked as dependencies: an Azure storage account, an Azure container registry, Azure Key Vault, and application insights. These are not part of your machine learning workspace, but these are like core Azure services that are linked to your machine learning workspace. So why is that? This is because whenever you are training something or training a model, you are creating some data, or you will be having some data. So where will you be storing all of that? So you have to store that in your storage account, and then when you deploy your model like as a service, like what are the errors and what is the uptime, and like how healthy your service is, that will be taken care of by that will be logged and available for you to use via application insights. Key vault is really important because you can see that there are a lot of services which are communicating with each other, and there has to be security, otherwise there can be a compromise. So what key vault does is, key vault is a highly secure service that is provided by Azure, that will have your all the credentials and authentication details so that all the services can talk to each other within Azure. So like that is the big plus point there. So even if you are interacting with the Azure storage, that you have uploaded something to the storage account and you want access to that in your machine learning interface, you don't access it directly. You access it via some credentials that are injected via the keyword, so that that is taken care of. Then we also have this container registry. What it does is, like, when you create the machine learning model, it saves it as a Docker image or a container, so that it can run on any cluster. You can run it on Docker Compose, or you can run it on Kubernetes, whatever you prefer. So that container registry is there. It pushes that image up there, and you can then pull it from on any of your clients, and you can use that as well. So that is there. Also, there are certain link services like compute targets and data stores. This will be really important. Compute targets basically means, like, where will you run your computation? Where will be the processing happen? It will not happen on your workbench. Like, it will happen inside a certain machine inside your workbench. So that is there. And there are data stores, then that is like the data stores are connected to your Azure account, storage account. So all of the references to that data is stored in the data stores. And then you also have some assets, like you can see in the diagram: environments, experiments. We will be covering all of those, because we have to understand all of that before we go into the drag and drop interface of this entire thing. So that is there. And okay, let's dive into that and get ourselves a machine learning workspace. So when we created that create resource and add a new machine learning resource in that Azure portal, once we click on that, we will be greeted with this screen, which will be asking us, like, what is the name of your workspace? And there is something called a resource group. What is a resource group now? And then there is a region setting here, and storage account, key vault, and application insights, just like you saw in the diagram. So here, first of all, we have to understand what a resource group is. So you must have worked with different projects if you are doing some coding, and there are a lot of files that are part of one project. In Azure also, if you are doing a project and you want to organize all of those resources into one single project, you can create a resource group for that. It's a really handy thing. So you have that resource group, and I did not have any resource group, so I created a new one with the name ml-rg, so that is there. And then the workspace detail, we have to give a unique name to this workspace. And then for the region, you can select any data center, like you can select Mumbai if you want like Asia based data center. I have gone with the default East US 2. Then the storage account, the key vault and application insights, you don't have to create them yourself. When you create this workspace, those names will get auto generated, and like a new services will get created just like that. So you don't have to take care of that as explicitly. Of course you can, but that Azure portal will take care for you. You can go into the networking, but here we can just go ahead with review and create to just see that what happens next. So once we click review and create, like it will go into this stage which will say that validation has passed. So it will just see that all of the settings that we gave and all of the names, the unique names that we gave to our projects, our resource groups and workspaces, those are unique. And once they are unique and all of that will work, if we can determine that, we can go ahead and click on create. So that will create our machine learning workspace, and that we can access. That Azure Machine Learning Studio we will be then be able to access. So once we click on create, we will be having the screen that deployment is in progress. So as you can see, it will create all of those key vault, application insights, and the actual machine learning workspace. So that is really handy. And once the deployment will be complete, you can then go to that resource, and then you will have this screen where this will be like the resource that you created, the machine learning workspace. But there is the studio web URL that will be the link that will click to get access to this Azure Machine Learning Studio. So just quickly take a look at how we can do that. So let me minimize all of my screens, and let us create a new resource group, and then let us go ahead and create the machine learning workspace. I already have a machine learning workspace just to demonstrate in case things go south, but those that will not happen. So I clicked on create new resource and clicked on AI plus machine learning, and I see that there is a product called machine learning. I can click on that to just like learn more about that, or just clicking on that brings up this form. So here it is asking that, first of all, what is your resource group? So I'll say I am creating a new resource group with the name MLSA dash RG. That is my resource group, like that is my project name. uh, then for the workspace name, I can say MLSA ML workspace. So that is my workspace name. And for the region, as you can see, there are a lot of data centers. I can click on Central India or like East US or something like that. Let me go with East US 2 only, just like because it is like the default one. And then you can see that there are storage accounts, keywords, and application insights. Those are auto generated, and that works for us. And these are unique names. Do not need to have some particular name. These can be unique, and you can just copy if you want these settings. You can see that the container registry is selected as none, and why this is, we will come back to it. It will not create the container registry right now. Even if that is a dependency for a machine learning workspace, it will not create it at this stage. We will click on review plus create right now, and then it will like show us what are the different things right here, like whether all the settings that we did were correct or not. So if all of that is correct, we will click on create. So that will create our machine learning workspace, and it can say you can see that it has submitted the deployment, and this resource group is being created. And once this resource group will be created, we can get access to the machine learning studio. Right now, the deployment is in progress. So as this deploys, I'll not waste much time into showing this. Rather, let's go into the presentation because we have already seen how the machine learning studio will look like. So as you can see that it is being accepted and deployment is happening. So right now I will go again back to my slides. So then we can see like what happens once we get into the machine learning studio. So like this is the machine learning studio that we have. So as you saw that we have to define some other services as well, like compute and data sets and data sources, data stores. So how we can do that, we will now take a look at that. Because see, compute instances are the compute targets are really important, because that defines where your code or where your algorithms will run, because that takes real energy. So you have to define that where should it run, and then you have to also define like what storage it will use, like where is the data and what data you will use in your project. So we have to define that. So now let us go ahead and do that. In the sidebar right here, you will be able to see like there is something called compute, and we will use these tabs on the sidebar to get access to all of these things. So we will click on compute. So once we click on compute, we will be able to like do all the compute, create all the compute targets. So what is a compute target? It is any machine or a set of machines that will run your task. So all of your processing will happen inside these compute targets. And inside the machine learning workspaces, you have some special types of virtual machines that will run your code. First is a compute instance, like that is a one machine that you can have, or you can have a set of machines, so that if you have a really large data set, so you can break up your data into parts and then assign a subset of data to each node. So you will have then have the entire cluster of machines. So that will be your compute target. You can also use your own machine or your own Kubernetes cluster if you want. So after you click on this compute tab on the sidebar, you will get access to this page. Like it will show you like to get started with Azure machine learning, you have to create a compute instance. So you can see there are compute instances, compute clusters, inference clusters, and attached computes. And we will be going through all of these one by one. So let me see if all of those deployments are complete or not, so we can create a compute right there. So yeah, it has completed. The deployment of our machine learning workspace is complete, as you can see. Now I am going to that resource, and here I have that resource. Here I can see that I have the studio web URL, and I can click on that. Here I go into the machine learning studio for my resource group. So as you can see, I get access to that interface where we can do anything, uh, anything related to machine learning. And this workspace can be shared with many people on your team, given they also have an Azure account. So we will go into compute. We will click on create a new compute instance. You can also create a cluster if you want a cluster of a set of machines, but I'll go with an instance. So for this right now, you can check some settings like what resources do you want, how many cores and how much memory you want for your virtual machine. So I can give my virtual machine a name such as MLSA VM, and it will all you can see that it has selected East US 2 as its location, but it is not changeable because your machine learning workspace is in East US 2, and you cannot choose your location outside your workspace. If you want to use another virtual machine or your own machine like as the compute target, then you can attach your compute as like a remote machine, so that will work that way. You can have a GPU attached to your compute instance as well. And you can now select from all of these different options. There would have been many different options, but I already have a VM running and my quota is like 6 cores, and I already using 4 cores. So I can also only see that there is only one type of virtual machine that I can have, that is having 2 cores and 14 gigabytes of RAM and 28 gigabytes of storage. So I can click on create, and that will create the compute instance for me. And all of the algorithms that we will be talking about and creating will get run, like it will be packaged up in a zip file and it will be sent to this compute instance, and all of the processing will happen within that. So once this is created, we will let me just show you how it will look once we get access to this machine. So let me just present my slides once again. I'll be doing a lot of back and forth between my slides and my desktop, just because to maintain the flow. So once we reached this compute instance creation page, we created a compute, and once that is created, we will see that it will be running, and it will have a private IP address within the Azure workspace. So and then we can go ahead and connect to it if you want, but we won't. We don't usually want to connect to these compute clusters because these will be managed by Azure Machine Learning Designer itself, and we will come to that in a bit. So our compute is taken care of. Now we have to take care of the data that we will be using for machine learning. So in Azure, what happens is you do not create a copy of your data. And why this is important? Like if you have a really large data set that spans hundred of gigabytes, and if you are just cloning that data set into your workspace, that does not make sense because you will be paying for double the storage. So that is impractical. So what happens is it creates a reference that is a link to that data, wherever it was. Like if you have a local file, it will get uploaded to your Azure storage account, and the data, that link will be created. It will only one copy shall remain on the cloud. You can also use some publicly available data set, and that will be cached once, like it will be downloaded once to the Azure storage account, and that will remain there. Also, you can use some Azure datasets that are already there, and also use some of your own databases and datasets that you have might have created through other Azure services. So those are the data stores, and then for a particular machine learning workspace, you have to register all of these data stores and as data sets, because your data store may have multiple files, and you might want some of the files to be like opened as text, and some of them might be text, some of them might be images, some of them might be videos that you want to run all of those fancy algorithms on. So for that, we have two types of data sets: the file data set and the tabular data set. So file remains as is as a binary file, and for the tabular ones, so we just parse it as a text, and we then give it a structure and register it as a dataset within Azure. So how do we do that? So first we will have any one of these, like public URL or a local data file or a Azure dataset, and that will get uploaded to Azure storage account first. Then it will be like a link to that will be created in our workspace as a data store. Then our data set will like define whether it is a file data set or whether we want to treat it as a text and parse it. So we can have that data set as well. Then you can run all those algorithms, and then one outcome of this might be like once you are doing all of this processing, some of your original data might get changed without your intervention, and that might not be what you want. So there might be a drift in the data that is occurring, and if you train your model with that different original data set within the same training cycle, what will happen is you will reach some inconsistent state. So for that, there is a data drift removal algorithm also built in into Azure, so that whenever you are training, you are sure that it is the same data set that is being used every time. So for this session, we will be using a data set which contains records from different patients. This is a diabetes data set that is sourced from the National Institute of Diabetes and Digestive and Kidney Diseases. So this is the data set we will be working on. Why? Because this has a lot of like medical factors. As you can see, plasma glucose, number of pregnancies, the blood pressure, and the insulin, BMI, and the age. And that what the data set already has is like it is giving us all of this medical data and telling us what was the outcome. Like, does this person has a type of diabetes or not? So like that, all of this information is already there in our data set. So this data set can be found at this link aka.ms/diabetes data, and we will be using this data set to predict whether the person might have diabetes or not. Like if we have all of these test results or like all of these medical values, and then we can ask our machine learning model to determine that if we have all of these set of data, that what is the chance that the person might have diabetes or not. Obviously it is not error free. So this is the sample data. Like we will be having a patient ID, pregnancies, plasma glucose, the blood pressure, the thickness of the skin, serum insulin, BMI, and the diabetes pedigree. Some it means something in medical terms, and then the age and whether the person had diabetes or not. One means that the person has diabetes actually, and zero if not. So to register a data set like this, what we have to do is like go into the dataset tab on the sidebar of Azure, the machine learning studio. So we can click on dataset and we will be asked to register a new dataset. So once we hover over this create dataset window, this button right here, we will be asked whether we want to upload our own file or use any URL and use from that. So once we click on create from URL, we will be getting access to this pane again. It will ask us to provide like the link. Where should I get the data from? Because I am wanting to take it from the same URL that I just showed. And I'm giving it a name that it is the diabetes data, and it is a tabular because this is not an image file or something. This is like a CSV, and I'll show you how the data looks like. Actually, let us take a look at that right away because that will be really interactive. So once we have access to our machine learning, uh, see this compute is already ready to go. We can go into the data set and let us create a new data set. And as you can see, we can create from a local file, from a data store, from web files, or an open data set. I will click on from this uh, web files and then paste in my link here. So here I'll provide like https aka.ms diabetes data. So once we have that, we have to give it a name. Let me give it a same name, diabetes data. This is a tabular data set and database description, diabetes data set. We can skip the data validation in this part. If you don't skip, it will just we can skip it, but if you do not skip it, it will show you like whether there are any missing values right away. So one processing step will already be done, but I am skipping it for a reason. So once we have selected that, then it is asking that what is like the format of the entire file. So it is a delimited file. Why? Let us just go back and see what this data looks like and why am I saying it is delimited. So if you see that, it is a comma separated file, and all of these columns, all of the different column data, it is separated by a comma. So that is why it is a comma delimited file. So it is of the type delimited, and delimiter is a comma. And the column headers, we can see that this is the column header, and we have only one file, so only the first file has our headers, and we don't want to skip any rows, and our dataset does not contain any multi-line data, so we can go ahead with this. So okay. So right now we can see like if we can see the schema of the data set if we have that, and then like if it was a file, it would have shown us the entire schema, like what are the different details, what data type it is wanting to. If I skip data validation, I think it can then loading the entire it can load the entire data set into the Azure data store, and as you can see, it has already pulled the data, and it can now just you can just explore the data that it is the right data that is coming in. So only the first file has headers. It is a delimited file with a comma delimiter, and that is fine for us. And we can go ahead and create this data set inside our machine learning workspace. So it is getting created, and this has successfully been created, and let us see what data set has it created. And if we click on explore, we can see that all of these different fields that are there, like BMI, serum insulin, and all of this data has been imported correctly. You can also click on profile, and you can have a big level picture of what the data looks like what is the statistical significance of this data, like what are the different uh, minimum maximum values, and if there are any errors in the data set. You can take a look right here. So now let us go back to my slides. So we have our data, and we have the machine that we can process this entire data on. So I'll resume my slides. So we have this data, and yeah, so what I was saying is I think it was taking some time to process, but uh, if you give it some more time, it can already infer all the data types that are there in the entire data. And then we went ahead and explored our data by clicking on that create button, and going to this explore tab. So then we have the entire data set. Now we have to go into the designer. Why? Because we already have taken care of the where our data will be processed. We have created and registered our data set within that entire workspace. Now what we need to do is take a look at the other parts of that machine learning workspace. That the first step is the designer, and this is what the workshop is originally about. This is a drag and drop interface inside Azure Machine Learning that allows us to create like a workflows. So this is the designer tab. So if you click on the designer tab right here, you will get access to this entire page. So it is asking us to create a new pipeline, and there is a lot of stuff right here. So let us go step by step. Like, let us revisit what is the definition of a model again. So model will be a piece of code that takes some input and produces some output. We have to select an algorithm, provide it with the data, and tune some parameters in the model, like give it some arguments. And then we have to train it over the data multiple times so that it can create an accurate prediction. And then, as you saw, that we can bring model from other frameworks as well, and also we can create it within Azure Machine Learning. So that is our definition of a model. And then we saw that designer was asking us to create certain pipelines. So what is a pipeline? The pipeline is a blueprint of what you are going to do. How do we come to train the model? If you want to train the machine learning, if you want to give the machine some learning to do, how would you want to do it? Do you want to do something different in between, like with the data, before you hand it over to the model? And what type of model should I train? What is the algorithm? What is the selection? And once I have, for example, if I have uh, trained the model, then what to do? How do I arrive at a prediction? So all of that is an entire flow of steps that you have to define. All of that will be defined by the pipeline that you will be designing inside the designer. So these pipeline steps will stitch together different phases of machine learning, like data processing and training, validation, and then the deployment also. These pipelines will have different data sets that will be that I'll show you how do they look inside the designer interface. You will have a canvas basically, and you can drag and drop different data sets within that canvas. You can drag and drop different modules. What are modules? I'll come to that again. Then once you have the entire flow of events that you want to do to train that model, you will submit that to that compute target, which machine that it will process the entire things on. So that will be known as a pipeline run, that you have run that pipeline. And that will be also for auditing purposes, it will also be organized into something called an experiment that will have the entire list of pipeline runs that you did. So all of this is a sort of code in itself, because you are defining visually, albeit, that what has to be done at each step. So that is an algorithm in itself. So that is a cool part of that. So this is the canvas that I was talking about. Once you click on the new pipeline button, you will get access to this interface that this is the canvas and there is an error here, and I'll just show you why that error is coming. And then you will have this entire list of modules right here, and you will have some settings right here to take care of. First of all, it is asking like, where do I run my computation on? Then we have to like go ahead and select that which machine I want to run it on. If I click on one of these drop down menus, we will be able to see many different types of things that will be there. Here you can see that I have selected that compute target. Here in the dataset, because we had registered that diabetes dataset, it will appear like a block right here, which we can drag and drop into the interface. So once we drag and drop such kind of blocks into the interface, another pane will open right here. That it will show you some of the parameters that it is like a data set, it is a data frame, and like all of these other metadata that about that data set that will come. And also you can see that there is a small circle right here, and this small circle that it defines like what you can get something out. If it is on the bottom of the this rectangle, it will mean that you can get something out of this data set. Here you can see there is one output, that is the data set output, and you also have an option to visualize that within that this interface. So you can see that we saw this data set earlier again when we were registering the data set, but once again we can see that we can explore everything from within here as well, and we can get access to all of the statistics that are here. Now, this was about data sets, and then we come into the different modules that are there. So one module may be just referred to as an algorithm, a single step of code that you will be performing on your data or any data that is coming from above it. So it may also have some arguments, and when we drag and drop one module onto the canvas, a pane will open. It will show all of the parameters and what outputs that we can get, and if there are any parameters to set, we can set those. uh, it will have all of those circles that are there that will represent whether we can get an output out of that module or not. And all of those modules have to be connected to one module or the other. It cannot be in isolation that one module is sitting without any connections to it. So that will be taken care of. So right here you can see, just notice one thing, that we can get this data set onto the canvas. So let us reach that step quickly in onto our actual live demonstration, so that we can get access to the modules and the designer interface, and we can quickly work with them. So right now you can see that I have created a new pipeline, and this is the interface that I get. I can rename this entire pipeline as diabetes training pipeline and save it. And still the error has not gone because I have to select a compute instance. You can select a cluster or a compute attached compute as well. I'll be selecting this MLSA VM that I created while I was creating a compute, and now the error has gone away. Right now, if you click on one of these drop downs, you can see that there is this diabetes dataset that we created. There are different machine learning algorithms from ranging from regression to classification, clustering, and there is a lot of stuff there. You have no boundaries. So we can use this data set as a block right here inside this canvas. We will just click and drag. So now we get this entire data set in our entire the workflow, and we have access to that. And here in the output you can see the data set output, and you can even maximize this panel to just take a look at the entire data set at once. So here uh, you have the all of the columns that were there in the original data set that we imported. And just take a look at the different columns. All of them have different scales. And do you think this will be important in the future? A spoiler alert, it will, because you cannot make sense of different scales. Like one thing can mean that the value is in thousands, another thing can mean it is in micrometers or something like that. So that will hamper our entire workflow. So we have to do something about it. So let us see that what we can do about that. So I'll switch over to my slides once again. So right here, we imported the diabetes dataset into our pipeline. Then we took a look at it, albeit for a short amount of time. Then we took a look at different modules. So here is one such module, and why am I using it? I'll just explain in a bit. If you go ahead and search for a particular module that you want to use inside the search bar, you can do that. You can click on, you can search for normalize. And what I have done is I searched for normalize, and it showed me a block named normalize data, and I just dragged it onto the console, this canvas that is there. And it shows me a number of parameters that I have to provide it, and not all of these will make sense to you at this point. Like there's a transformation method, there is like a use zero for constant and the columns to transform. What do these mean? So for that, we have to take a look at why are we using normalization in this context. So let us go into that right now. So for why are we using normalization? Because we just saw that our data set had different scales. So one thing might be in millimeters or micrometers, other thing might be in thousands of cells. For example, if it is a blood glucose measurement or something like that, that can have different scales, obviously. And the number of pregnancies is like a number of individuals. That is another scale. So that will that the computer will the machine will get confused. They are not humans who have this intelligence that what should have this scale or the other thing should have another scale. So for taking care of that, we have to do something called normalization. So that is a part of data preparation. What it will do is like it will shift all the values and bring it onto a certain scale. Like there are multiple ways of doing this, and there are multiple algorithms, and there are pros and cons for each one of them. Either we can do this z something called a z-score standardization. What it will do is it will apply this formula, that is x minus mean of x divided by standard deviation of x. What it will do is like take the entire data set that can have a different arithmetic mean and some other statistics as well. So what it will do is make the mean of the entire data set 0, and the standard deviation, the maximum standard deviation, will be 1. What will happen as a result of this, it will fit like a standard it will fit a standard distribution. Like there will be a bell curve kind of situation right there, and it will be centered at 0. So that will be the work of z-score standardization. Other thing we can do is like min max scaling. We can take the entire data set, and for the column, for one column, we can range that values from 0 to 1. It's like the minimum value will be represented as 0, and the maximum value will be represented as 1, and you have the entire range in between. So that is the work of min-max scaling. And obviously there are a lot of mathematical functions like log normal and logistic functions, and you can use any of those, and you have the flexibility of using those. So right here, what I'm doing is what I want to do is like range these values between 0 and 1. So the minimum value for each column will be represented as 0, and the maximum value for each column will be represented as 1. So if we do that, then for that we have to select this min max from this drop down, and I'll be leaving this use 0 for constant as true. And for the columns to transform, what columns do we want to transform? So for in this case, we do not want to transform the patient ID, because that is of no use to us. That is not a numeric column, in the sense that it does not make sense in the entire. It can be a random string as well. Patient ID does not make sense. And also the diabetes class label, that whether the person actually has diabetes or not, that does not make sense to have a value like 0. 0.5, because we are treating it as a truth, like whether they have diabetes or they don't. There's nothing like a middle ground. So except all of those two columns, we can normalize all of the other numeric columns. So what we if we click on that, you can select all of the columns that you want, and you can just add all of the columns that you want to normalize into that set. So once you have that, that error goes away. Now you want to see like what will be the action of normalization on this data set. You just click on submit, and that is how you submit a pipeline run, because you just have a small part of a pipeline. even though this is small, this will also be counted as a pipeline run. So you have to like give it like which experiment you want to run it on. Experiment is like a logical container that contains all of the run history and stuff, so that you can come back and see what went wrong at which step. So you can set up a pipeline run right now and then submit it to your compute machine. So it will start running, and once it is finished running, another pane will pop up that will show you that these were the outputs. First, you will have a transformation function, and that will be the logic, the code that is generated for transforming all the data set that you gave it. The next thing is the transform data set. And if you explore that data set, you will now see that all of the data sets have been like transformed to have values from 0 to 1. You can see the plasma glucose, this value ranges only from 0 to 1 now. So we have come to a common scale, and there are no different scales right now. So that is one advantage now. Every value and every such factor, such as blood pressure and plasma glucose, all of that has the same priority for our machine, and it can use all of those values to come at a prediction. Now we have the data set, and that data set also has like a same scale, so that we can handle it really gracefully. We have to now train the model, and here is a decision we have to take, like which model should I train, like what should be the algorithm. But for that, I already said that in the beginning that we cannot use the entire data for like for training purposes, because then if you want to test out that whether my model is producing a correct output or not, you have to collect data once again. So that is not something desired. So we can split the data into two parts and keep a small part of it for testing later. So what I have done is I have searched for the split data module inside this search bar, and then dragged it onto the canvas. And then because when I dragged it onto the canvas, it was asking me for some parameters. I changed some of it to say that 0.6, that is 60% of the data, should be used for training my machine learning model, and take a random seed like 1 2 3. It will just take the random 60% of the data set and split it into one half, and the other part into the other half. And you can see there are two circles beneath this module. These are called as ports. So first port will have the first part of the data set, and the second part will have the second part of the data set. Once we have these two separate data sets from one data set, that then we can go ahead and search for training a module. Then I like this train uh, module you can drag. It is asking for two different inputs. The first input on the left hand side, this will ask for a module, like which model you want to train, like what is the machine learning model you want to train. Is it a logistic regression, is it a linear regression, is it a support vector machine, is it a neural network, what type it is. Then the other thing is like what is the data, which data should I train it on. So now to select which type of machine learning model you want to train, you want to take a look at this particular chart right here. It shows us what do you want to do. Here are a lot of use cases, like you can predict values, you can extract information from text, or you can discover structure from within your data. What we will be doing is like predict between two categories, because we have only two categories, whether a person has diabetes or they don't have diabetes. So that is a two class classification problem, two category. And even in that we have a different types of models, like all of these algorithms are available to us. So right now, what first I will be going ahead with is the logistic regression. Like that is one of the most common machine learning models used for classification. So we will be going ahead with logistic regression. Then I'll come back again and try out a different model, and show you the difference between the two and why one of them is better than the other. So we dragged we searched for train two class logistic regression right here in the panel, and dragged it onto the this canvas. And then we can see that it outputs something called the untrained model dictionary. And if we connect it to this train module right here, it's the error of the train module has still not gone away because it is asking for a label column. What do you want me to predict using logistic regression in this data set? So now what we will do is like click on that. Once we click on that, it will show us like what do you want me to predict, what is the column that will be used for like the label that I will predict, whether it is a class 0 or a class 1. Diabetes does not make sense to your machine, only a class 0 or class 1 makes. So whenever you try typing something out right here, it will show you like what are the different columns, and then you can select from one of these. So you will be getting to a stage like this, that you will have a normalized data. You can split the data into two parts. Here I've added some score module, but just wait for a bit. But we will have this logistic regression. We can train that model. Like this part, this upper half of the part of the pipeline is what we have covered till now. So let us reach up to this point in our live demonstration so that it is easier for everyone. So right here, we have to do normalization. So I'll just click on this search bar and search for normalize data module. I'll just drag it out here, and I will connect this data set to this module. I'll say that I want min max and which columns I want to transform. Here I can type out all the column names one by one if I want, but also here I can type everything I want. All of the column names are being displayed to us, but we can also add all of these columns and just remove some of the columns that we don't want to be normalized. So patient ID and diabetic, 0 or 1, we don't want them to normalize. We click on save and then we can run it, but I will not run it at this stage because I want to run it at once. So or you can run it step by step just for learning, and I have already done that in another machine learning workspace that I'll be showing you while this is training. So I have now dragged this split data module onto the canvas, and I'll say that I want to split 60% of the data, and use the same random seed value. And then we will use this normalize data, and I'll connect it to the first port. And there we'll have the first data frame and the second data frame. So it has split it into the training data set and the testing data set. Next up, we have to train the model. So for training a model, first we have to have this train model particular module, and that is there. And now for this train model module, we have this data that is coming from here. Let us connect that here. We also have another required input, that is an untrained model dictionary. So it needs a type of a model to train on. So just like in the slides, I'll be using two class logistic regression right here. You can see like there are a lot of parameters, but I'm not touching them and any of them right now. And I'll show when to touch them, and what automation can we do to just like change them on the go, because that is really important if you go into advanced machine learning. Those are called as hyperparameters. And like this is the logistic regression module. We can connect this logistic regression module to our train model step. All the required inputs have been connected, but the error has still not gone. Why? It needs the label column. I'll edit this column and just say that diabetic is my column, and that is where I want my predictions to come. Then I was just showing you that up to this stage, all of the data we have understood how this works up to this stage. Now let us go into the slides and take a look at the other steps that follow. Our the model training steps are up to this point only. From now on, we will be generating some predictions from our machine learning model, and that is where the score model will come in. So right now we have created our model. We have not run that yet. We will be running that at a later stage because that will take some time, in tens of minutes. So that is why I'm not doing it right now. So then I added a score model module. What it is doing, it is taking that trained model and then the other half of the split data. So this is the testing set. If you if you closely take a look, this is the testing set, because the training set went to the train module, the testing set went to score module, and the model itself went to the score module as well. Here, the what do we mean by the scoring? Scoring means like using the seeing the entire data set, and data set here means the test set, because the training data set is not connected to it. So it will take that test data set, and it knows to score the model I have to predict something called a column named diabetes. So I will drop that entire column from the data set, because I don't want to see that, I don't want to know what is the truth, I want to come up with my own version of truth. So it will take the model. The model will be like a piece of code that has been trained, that has seen all of the data, that has all the experience, it has learned something from the data, and then it will apply that on the testing data set and come up with its own version of truth, that is whether the person has diabetes or not, and then the probability of that, probability of whether the person has a diabetes or not. So for that, we will be using the score model module. So we can have classification models which will have the class, and for regression models we will have the numeric value. What is classification and what is regression? You can take a look at it if you go deep into machine learning. But like this session was only for creating and deploying models, so I am overlooking that part right now. Once we have that score model module right in front of our eyes, I am also adding another module just by searching from this sidebar here, that is called the evaluate model. What evaluate model will do is like get up with some statistics, like all of the accuracy, precision, recall, all of these have meanings in machine learning domain. So it is not always like that your model has the highest accuracy of being true, that means your model is good. You have to see some other metrics as well. So in Azure ML, when we apply that evaluate model module, it gives us all of these different types of metrics. Like if it is a classification module, you can get accuracy, precision, recall, F1 score, area under the curve. And if it is a regression, we can have mean absolute error, root mean square error, relative absolute error, and other types of errors as well. Like what is we have to minimize the errors and maximize the accuracy at this point. So you can use these metrics to like get an idea of how your machine learning algorithm is performing. Also here is how you evaluated a model, but now you are you are wanting to get the entire output and see like what are the you saw that it can produce all of these metrics, but how will it present all of these metrics to us? So you can go ahead and submit this pipeline run, and once it is done, you can take a look at the different output one by one. So if you click on score model and see its output, it will show you a scored label and a score probability. That is, this is the truth. That is, the diabetes column is the truth, and the scored label is our machine learning model's prediction, like its version of truth, and how much confidence it can say that the person has diabetes is in the probability column. And if you see the output of the evaluate model, it has a evaluation results. This is that output. So because where are these outputs coming from? These are the circles, the ports at the bottom of each of these modules. These are displayed in the output section on the pane. So if you click on evaluate model module, and click on the evaluation results, you can see there are a few sorts of graphs all over the place. You have the ROC curve, you have the precision recall curve, you have the lift chart, and you have all of these details. There is a confusion matrix in front of you. What are all these things? These are the metrics that you use to uh, classify that how well is my model performing, like how well would it perform in like the wild when it sees a new data set. So for that, you can use these metrics. I am not going into the metrics details due to the paucity of time, but these are the different data metrics that you will be getting out as an evaluation from that um, evaluate model module. So Now this is like for one model like that. This is the logistic regression output. What if I want to add another type? Like if I want to pit one algorithm with another, like if you have a quick sort and if you want to compare it to bubble sort, how would you do that? So this is that part. So what I have done is just like simply selected two of these models, like these train model and like score model. These two modules I have selected and copied it over, and got a new type of machine learning model, that is like a boosted decision tree. And let us see whether this boosted decision tree is better than our logistic regression or not. How did I come across boosted decision tree? If you just see this chart once again, in the same bag, in the same category, we have this boosted decision tree as well, along with the two class logistic regression. So I just picked up a random uh, algorithm from there. So once we run that again, then if you check the evaluation results, you can see that we have two tabs now, the left port and the right port. How did it come about? Because there are two inputs right here in the evaluate in the evaluate model module. So the first port is this is the confusion matrix, and in the blue you have like the results for the metrics for the logistic regression, and on the green side, that is the right port, this is the like the output and the metrics for the boosted decision tree. As you can see, just in layman terms, you can see that this accuracy, this is some sort of accuracy right here from the logistic regression, and the accuracy jumps up when we use the boosted decision tree. Side by side you can compare, like there are two different types of models. So one has some sort of some accuracy one, and so, this has a better accuracy, so you might want to use this model rather than the logistic regression model. So you have both of these comparisons side by side. So let us at least reach up to this stage in our live demo, so that we can be on the same terms. So let me share my screen once again. And here we have the train model module. Next, what we have to add is a score model module. I don't want to do anything else, only connect to this train model to this module. And the split data, I have to connect it into the score, the testing data. This is like the testing data. I have connected it to the score module, score model module. Sorry for that. So next we have to evaluate this model. So we can connect one of these ports right here. And what I showed you was like I pit two different modules against one another. So I selected both of them by pressing down shift on my keyboard and control C to copy all of two of those models modules, and like control V, and I just created a duplicate of both of them. And now I can have another let's say one on the another algorithm. Let's say that was decision tree, right? Two class boosted decision tree. This is searching canvas. I want to search for all the modules. uh, Two class boosted decision tree. Then I can drag it onto the canvas just like that. It also has some different uh, parameters that we can tune. Right here, I can take the output from this and train model. The first input port takes in the untrained model dictionary. So this is the untrained model that went there, and I can use the training data to train this model again. Now we have to score this model. I am using this train model output, and for the testing for this boosted decision tree, I can use this testing data again for like testing, and I can use the output from this core model and use that to evaluate the entire model. Once that is done, like this is our entire pipeline, and we can now submit this as we want. So here I am like we have to create a new experiment because we are running it for the first time. So I'll create MLSA run. This is the pipeline run in this experiment, and we will continue on failure step. This means I just told you that the pipeline runs are cached, so that if you have already run one pipeline, the outputs are already there, and if you want the same output in subsequent steps, the same output will be used instead of calculating this once again. And you can use the virtual machine that you had created in the computation part to do the computation here. So right now I submitted the pipeline run, and this run is preparing. So when it is like starting, you will be seeing that this is not started. Some of these models will be like getting queued, and it will change status to running, and then again it will be completed. So just for a quick shortcut right here, I had created this entire pipeline beforehand, so we can see that. So I'll just change my current workspace into another workspace, that is the another machine learning workspace, and we can go into there so that we can take a look at what is happening right there. So if I click on this other resource group, I can go to this resource group, that is the MLRG. That is a different resource group than what we have. Here I have like a machine learning workspace, and I can go to its own studio. So here I'll also have this access to the designer, and like this is the diabetes training pipeline that we also created in this session. So all of these modules have completed running in this particular workspace. So after normalized data, what we see, as you can see, if you see the transform data set, all of them are in the same scale. Then we can split the data. You can see that two data sets have been created: results dataset 1 and dataset 2. This contains 60% of the output of the data, and this contains the rest remaining 40%. Here the model has been trained, and you can see like there is a trained model right there. You can even download this you can register this model, like if it has trained, so you can just export this model out of Azure machine learning and use your own framework. Like if you want to use TensorFlow or PyTorch, you can use that. Two models have been trained right here. One is using boosted decision tree, one is using logistic regression. Both of them have been have scored the data set. That means both of them have created some predictions. So this is the predictions from one of the models, and like this is the prediction from the other model that is there. So like these are the different models, and these are the probabilities. Like what is the probability of this person have with this data? What is the probability of them having diabetes? Then in the evaluation, you can see that whatever we just saw in the slides, that is available to us, like in the left port and the right port. Here the model has an accuracy of 95.7%. Here the model has an accuracy of 78.6. So we go with this right port, and this right port is coming from this particular boosted decision tree. So that is why we went with that. So let us again come back to my slides. So we did our training, and our machine learning model can make predictions at this point, but it will not be able to make predictions out of this canvas. So we have to fix that issue. We have to take this out in the wild so that everyone in the world can access this machine learning service. So for that, we have to make predictions for the end user. So for that, when we created this pipeline, we ran it. Once it has succeeded running at least once, another option shall come. That is to create an inference pipeline. Inside that also, it will show you that real-time inference or a batch inference. Let me break that down. What is inference? Inference is like if my model is getting some data as an input, it has to make a prediction, and that step is called inference. Like it will infer the prediction out of that of that data set that is there. So we will infer from a particular input, and we'll make the predictions, and we will be delivering it back to the consumer, like whoever made that request to let me run the predictions on. So that is the real time prediction inference pipeline, or prediction pipeline, you can say. That it will in real time we will get the data, and in real time we will get send back the predictions. Another one is the batch inference pipeline. Like you have collected the data again, and you now want to run the machine learning model on that data. So you can upload another data set and you can run it on that. So that is like the batch inference. Once you click on like real time inference or batch inference, two things happen. First thing is like this evaluate model module goes away like logically it goes away. It does not in the machine learning designer, because you still have some debugging to do. But one things that goes away for sure is like the training steps. Like you do not see a training model module right here. There is no train model module right here. It has generated, it has taken the blueprint from that training module and created another pipeline of its own. And this flow now represents what will happen if I get like an input that can be from a data set or like a web service. Like from a website I can get some data through an http request, and then what we will do to get a prediction. What is happening here, just take a look. First is like the normalization function. Like we transformed our data, right, to get it into the same scale. So when we receive new data, that will also be in different scales. We still have to like transform it into the same scale. So for that, whatever we normalization we applied during the training, we are applying the same transformation, that is the normalization step, once again on our input. Then there is, this is our model that what we trained. This is like stored into the Azure storage somewhere as a file, and that we will be use then we will be using the same score model module. Once again, we'll be using this model right now. We don't have to train it this time. We will just use that model, and then we will be using this transform data set, and then running the predictions, and whatever predictions we get, we then just throw it off to the web service output. Like now whoever made that request through the website, it gets all the predictions back. From the website I got the name as the patient ID, the age and the number of pregnancies, the blood glucose and the serum insulin, and all the other factors like that. And then I predicted whether 0 or 1, like whether they have diabetes or they don't. And like I sent it back to the request, uh, whoever made that request. So for this, one thing we have to do is like once again we can choose, if you want this to run on a different machine than the training one, you are free to go ahead and do that. So here, one thing we will be doing is like there is a step that is like worrying to me, that this is the diabetes data set, right, that we just trained our model on. What is it doing here right now? Because we have already trained it in this on this data set. Our model has already seen this data. It has no use of seeing the same data once again. We will feed it with some new data, like something that that model has not seen before. One way we can do is like enter some data manually, and then run the entire predictions on that, and then we can see that how our model is doing. So if you search for this enter data manually module in the manual data entry module inside the search bar right here, you can find this enter data manually module. Here you can paste in, because our original data set was in CSV, we just pasted in the some additional rows, some extra data that is there. Like this is some these are actually some rows from the test data set, like the last 3 rows, and I just copied it over and I'm just testing it manually. Like for this custom data input, what is our model predicting? Because I know what should be the output, and let's see that what is its output when it goes out into production. Then we can see that I have highlighted this evaluate model module, because we do not need it right now, do we? Because we there is no need for evaluation right now, because we have already selected the model that I want to use, and I have already trained it, and now I want to use it in like the wild. So I'll just go ahead and delete this evaluate model module. Where did it come from? It came from this training pipeline only. It just took the training pipeline and just made some changes to it, and there we have the inference pipeline. I will just remove that evaluate model module. So uh, then we will get rid of that. So let us quickly create the entire inference pipeline, then I'll be able to show you something better from there. So let me go into one another tab that was there. Let me switch my workspace back to the other one, that is the one that we created for this session, the MLSA ML workspace. And in that particular studio, we don't have access to this pipeline, but we will have access to our original training pipeline that was not run initially. So one thing I can just go ahead and do is like I can go into that other resource group that is there, MLSA ML workspace, and I can open up the studio from there. And that is like the flexibility. You can anytime go back to like the Azure portal and open up different workspaces. So this was our training pipeline, and all of it has completed now, is as you can see. This is the one that we created right away, right now, before we went off to see that the other pipeline. So right now it has completed. Let us see if we have the same similar kind of output or not. So let us see the evaluation results. Yeah, it is 78.6, and for the right port it is 95%. Because it is the same data, the results should be reproducible. I am creating a new inference, real-time inference pipeline. It is giving me an error because there is more than one trained model inside this pipeline, and that is true. I will just select that I want this boosted decision tree, and I'll click this is the model, not this algorithm. This is the algorithm. I want to select the model, so this is the model. So I'll create a real-time inference pipeline with that model in mind. So it is loading, and like it has now created this entire inference pipeline from that particular training pipeline. You can as I just said that I'll just go ahead and delete this evaluate model because we do not need it right now. Then I do not need this diabetes data because this data set has already been seen by our model. This is our model, trained model. I'll get rid of this data, and I will enter some data manually. So you can select as enter data manually, and drag it onto this canvas right here. Here you have to provide the data manually. So I'll just go ahead and get this sample data. I'll open it with Notepad. So I'll just copy it over, and like this is my sample data, and I'll connect it to the same place where the web service input is coming. And like this will be my inference pipeline. But the problem here is that I'll be sending the same data that is coming from the input along with the prediction to the output. Because what will be the like the outcome of all of these steps? It will generate a prediction, but it will also keep all of the different what we can say, all of the different columns. Just to show you what I am talking about, let me just show this other pipeline that is there. So this is some other workspace. Let me go into uh, let's say the previous workspace that I had created before this session, just so that I can show you what it looks like. So I'll go into designer and go into this other inference pipeline. This is the inference pipeline. So at this stage, what happened is I have scored the model, and what is the output? Let us take a look at that. It has like we have given it three rows, like three rows of data, and it has predicted for all of them. But the problem is that get all of the columns in the output, and I don't want that. Sometimes I only want that the customer or the client who is using the data as a out from the output, they should only get the prediction, not anything else, because that is known to that client. So I might want to select only a few columns in the output. So for that, what we can do is we can do two things. One thing we can do is like what I have done right here. Where did it go? Yeah, we can have our own like custom Python script we can write, because this is a data frame, and we can select some columns like in this fashion. One another thing that we can do is like we can take select columns in dataset, we can use this particular module. Apart from, if that is I showed you that Python script only because if you want to run some custom code in between, so that was my purpose of showing you that code. Otherwise you don't need any code. So you can select the columns in the dataset, and then you can pass it on to the uh, web service output. So you can select which columns you want. So I want the patient ID. So it is asking me that please run the modules before this one when you are auto completing. So what it wants is to me to basically just run it up to this stage. So we will get an error at this step because it does not know what to select, but still it will work. So uh, this parameter is invalid, it won't work. So let us just delete that, and then connect this to this module right here, and use the existing MLSA run experiment to for this pipeline run, and just let's just run this entire pipeline. Because we have entered the data manually, it is no longer running on the entire data set, so this should be faster first of all, and we should be getting a pretty similar output. So that is not what I am concerned with. So once we have done that, like we have selected a few columns in the output that we want to show to the client, then we can go ahead and like create like expose this over some IP address, or like link. We can first my point is like we can create a link where the websites can talk to each other, and then use this model to get the uh, predictions out. So let me go back to my slides, and right here, yeah. So once we have that all the that prediction capability from our model, we have created this entire Python script. As you can see, like this is the Python script I was using. Just like in pandas, I am just selecting this data frame one. Why data frame one? Because I am using the first port in the execute Python script. So two data frames can be there, and the third is one for is if you have any other external Python modules that you want to use in this script, you have to supply them right here. So two data frames can be used as input. So we have the two inputs. I'm using the first input only, and I'm selecting a few columns right here, only the patient IDs, code labels, and code probability. And if you can see, I am also renaming some of them. So we have this flexibility when we have some custom code. If you are using only the select columns in the if you using that module just without any code, you may not be able to rename. You may only be able to select like what columns you want in the output. But here you can very flexibly like change the code and rename your columns. So once we have done that, we set up the pipeline run, and after that you can see the score model output is like this. All of the columns are there, and after executing the Python script, or like selecting all the columns in the selecting those particular columns in the dataset, we'll be only be left with these three columns that we can use. So like that was like prediction. You have created a model and successfully getting predictions out of that. Now the only steps that is needed is to like expose this over a particular link so that anyone can use this model, then submit all of their medical values like all of the age, BMI stuff, and get to know whether they have diabetes or not. So for that, we will be using a technology called Azure Machine Learning Endpoints. So these are like services or links. You already get this entire HTTP link to yourself that your client, HTTP client, or any app, or even your browser can use to like receive the predictions. So you can send the data and receive the predictions. What is the plus point of using the advantages of using endpoints? Like it already has authentication built in. You don't have to create another separate app for like loading the model and predicting handling all the requests, like taking the parameters out of the HTTP request, like whatever you are sending. Basically you don't have to like filter everything out and call the predict function on the model and then evaluate stuff like that and send back return HTTP response. This will all do it for you. What it will do is like take your model and that inference pipeline, it will generate the code for that. There is a code generator there, and it will generate the code for that an entire web application. It will use your model that you created, and it will create a container image that can be run on any cluster or any uh, Docker instance. Or so you have a Docker image basically, and you can run it on any other environment as well. So there is this is where the container registry comes in, because in the Azure machine learning workspace, you had key vault, you had a container registry, you had a storage account, and you had application insights. So here is where the container registry comes in. Your model is ready, your inference pipeline is ready, all of that is packaged into a Docker image that is like a disk image, and that is then pushed over to the container registry, and then a cluster node then pulls your entire model and code and then runs it, and that is your endpoint basically. So you get a stable, like it will always be in this fashion, like endpoint name, region East US 2 or Central India, inference.ml.azure.com. That this will be the format, and it will have all the details, like what version of your model you are using, and what are the parameters that you passed on each step, and everything of that kind. So if you click on deploy after creating this uh, at this stage, if you click on deploy, then you will be greeted with this another pop-up, like create a new endpoint or replace an existing one. So we will be creating a new endpoint, and if you just give it a name, then it and select where you want to deploy it. Here I'm using a container instance. Another option that you have is on Kubernetes. So if you have a Kubernetes cluster, or you set up a cluster instead of an instance in the first step when we are setting up the workspace, then you can use the Kubernetes service. So Azure has Kubernetes, it will deploy it there. So like that is the part where you deploy, and this pop-up comes up that your endpoint is being deployed. Once everything of that sort is done, then you will be presented with this screen that will have your link. Like this is the link. If you use this link, you can like talk to your model basically. So let us reach this step in our live demo. And I see that we are running out of time, but this is really important at this step, and it will be really satisfying once we get the hang of it. Here I said that I don't want everything right here. So I'll just say that I want select columns in a data set, and for just simplicity, I'll be using that other workspace for the endpoint, because deploying it here will take some time. So I'll be connecting these two and selecting the columns in the dataset. By name, I will be selecting patient ID, scored labels, and scored predictions. So those are the labels that I want, nothing other than that. So once we now before we deploy it, because I made a change to this entire pipeline, I have to run it again. But you will see that I will not be running all of the steps again. I'll be only running from the core model step, because all of the pipeline outputs are cached. So like that will be the thing. Now it is running, so all of these are already completed, because that was there. And this core model is queued only because this can be a web service input. Up to this stage, all of that should be cached, and this web service input could be anything. That is the reason it is running again, because through a website any user can pass in any different values, so it is not possible to cache that part. So it is creating all the predictions out of our model, and once it is completed running, it will select only the particular uh, mm, columns that we want, and that will be like our output to our web service. So let us assume that this will finish, and it is already finalizing. There has been no error, so we can go ahead with that. So it will be now selecting only the columns in the dataset. uh, I can see like this is the score data set, and it has all the labels and the probabilities. And once we have the output of that, we will be only having only those three columns, like patient ID, scored labels, and scored probabilities. So here, what I am saying is like, if we deploy this endpoint from here, like once this is done, we will be able to deploy it. I'll just show you how to deploy it from here, and I'll show you the endpoint that I created earlier. So once this select columns in dataset is done, it is running and it will be finalized pretty soon. So it is finalizing already. Let me just wait for it because that will make things seem a bit more clearer. And thank you all for like hanging out with me for this entire duration of 2 hours. It's not that easy. And do not worry, you will all be getting your certificates, and like I'll be getting your attendance from Teams itself, so don't worry. If even if I don't have your details, I will find those out. So here you can see like I only get only these three details. But like this in other workspace, what I had done is in this pipeline, I had done a Python script instead of that select columns. Here my columns are renamed, like scored labels became diabetes prediction, and scored probabilities became probability itself. So that is the thing. Once now this has been completed, here select columns in dataset is completed, I can go ahead and deploy it to like MLSA endpoint ML. So like this is my endpoint, and I will be selecting container instance, and like just like that, my machine learning model is ready to be used by anyone else in the world. So it is obviously it is waiting for to create that, and it takes a good 20 minutes, and I'll not wait for that. Don't worry. But yeah, that is how you do those things. Here you can see you will get access to these endpoints, and this is like the endpoint that you will get. So it will be healthy when it is completed deploying. It will show some other states like unhealthy and transitioning, and at the end it will be healthy. And then you will have this rest endpoint which you can use to like get all these predictions from. And there is the Swagger URI, like if you have some API specifications, you can import that. So how do we use this rest endpoint now? So let me go back to my slides. So we will be you will be able to use this particular link to make our predictions from other websites and apps. And I'll just show you that part, and like that will be it for this session then. And let me resume my presentation. And you can see like there is a details tab right here, and this was the link that we just saw, the REST endpoint. There is a consume tab, there is a deployment logs, and there's a test. You can go to test and like provide some values, like random values that you want to test. You can test it out right here. You can provide different values, and you will click on test, and it will show you what our machine learning service is providing to the rest of the world for this input. So that is there. Also you can provide like the entire JSON in some format, obviously in some schema. And then all of these details should be there, like patient ID, dependencies, whatever that was in the data set, it should be in the same uh, format. And once we give that, we get all the output in the whatever it made the output, like diabetes prediction one. Yes, this person has diabetes, might have, I must say, or they don't, or they might. And these are the probabilities for each one of them. Like this was like the interactive, you can test it out for particular values. What if you want to integrate it in your own application? There you will be needing to consume this API. So for that, you have this entire link. So this will be the place where we will be making your requests to, and this is like the authentication token that you will be using. So if you are into web development, you must be knowing like we have something called uh, token authentication, that we use authorization header and a bearer token, and that is how we authorize our requests. That makes our HTTPS requests even more secure. So this is that part. You can have some demo code in Python and R and C sharp, and like you can see like how you can integrate all of those applications. So this is that part. You can also use like various industry standard tools like Postman to test all of this out. So here what I have done is like copied the entire REST endpoint, pasted it right here. here is my input, and this is my testing data, some random data that I am testing it on. In the authentication tab, I have selected token authentication, bearer token. And what I have done is like I have taken this entire token from this page right here, whatever the primary key is. And then I pasted it right here. So that will help me authenticate myself with that endpoint. So if I run that, I get the prediction. So this is big. So we went from providing inputs to our machine learning services at this point, at this endpoint, and I sent it these particular details, and it did the prediction and sent me over the results for this prediction, whatever those are. So that is how we got the predictions. One other thing you might be wanting is not use Postman and use some real code, like want to write some real code. So for that, let us spin up a notebook that is like a Python development interface. You can use Jupyter notebooks, or ideally for that, does not matter. You can even use VS Code. It is recommended to use VS Code, obviously, but like you can use notebooks from within Azure ML as well. So you can create a new Python notebook. And this is a Jupyter notebook. If you are not familiar with them, these there are some certain cells. You can write some code in them, or you can also write some text along with them so that it is clearer to the user or whoever is using this notebook to like. It will be good for documentation, and a lot of researchers also tend to write some explanations, some mathematical expressions along with that, like what they are doing in the next code lines. So that is really important. So what we have right now, it is a development environment, and I am writing some Python code. Nothing else. I'm just writing some simple Python code. Here you can see, if you can select different Python versions and even R. So you have different languages and different versions and different machine learning libraries pre-installed into this environment. So you have that flexibility as well. Here, this is my first bit of Python code. What I have done, I have declared a Python dictionary, and this is a nested dictionary. And all of these different properties are nested in here, just like it was in the JSON which I sent over in Postman. So in the same shape, I have declared all of this data. I've imported the JSON module. Why? Because I want to send it as a JSON, and I have encoded this as a byte string. So you can take a look at the Python documentation for this. Like, what does string.encode do? It converts it basically into a byte string from a regular string. So that is there. Then I am importing the requests module. Requests module, if you are not familiar to that, it enables you to make HTTP requests from within Python. So if you are making any web scraper, or like if you want to do any sort of uh, request making from within Python, you can use the requests module. What I am doing is I am sending a post request. Again, HTTP request, another video, or any other documentation you can consult. I am sending a HTTP post request. The URL will be that endpoint which I got from Azure ML. The body will be this entire JSON object that is there, that is now converted into a byte string. That will be my body. And headers, I have to select this authorization header, because it will not allow any random user to make predictions and exploit our model, because running our model takes resources, and that might cost you in the wallet as well. So we have to authenticate ourselves, like only our website or only our app makes use of this model for that. And our content type is JSON, because I am sending JSON, so I want to let the server know that this is JSON file. So the server knows what to do with it. Then after this is done, like when I just write it like this and execute it, what it will do is like execute the post method with all of these keyword arguments, and I'll be getting something in R. And if I print r.text, I can see that this is the output that I got from the server. So that machine learning service took our input, that is all of the input right here, and provided me like with all of this output, like probability of the person having a diabetes, and like the whether they have diabetes or not, like what is our prediction of that. So like that is how we can integrate different applications with our particular machine learning service. So I'll just show you within Postman how it is working. So I just opened up Postman and I have copied the URL from that machine learning service, and like I can just save it right here. I have already provided it the token as I was taking the screenshots. Here, let me do something. Let me change some of these values. Say, let the plasma glucose is 71, diastolic blood pressure is 76, and triceps thickness is something like 20. Serum insulin is 20. It does not need to make sense because it is not making sense to me, but I am still doing it. BMI is 21, diabetes pedigree, let's say it is 2.3. I don't know what that means. Age is, let's say, 27, and pregnancy is, let's say, 3. And like if I run it with that, it will make some predictions, and it says that no, this person may not have diabetes. So like that was our prediction for this entire particular data point, that with these set of values the person does not have a diabetes. So like that was how we could integrate like our entire application. Like we can write some code like this, or you can use just for testing you can use Postman. So like that was my point in how you can integrate the machine learning service into your application. And after all of this, we are basically done, but we also have to clean up our whatever we have done, because that will cost, if you keep everything running, that can cost us some money. Because you have your compute services running, you have your storage services that are storing your models and stuff. So we have to take care of them, right? Our basically our demo and our entire thing is done. Like we have created a model, we have trained the model, we have taken predictions out of it, we have deployed it to some place where everyone can access it, and then we are now just cleaning our traces up. So we will go to Azure portal, not the Azure machine learning studio, because we don't like to self destruct, let's say. uh, we will go into Azure portal and we'll go to this resource group that we had created while we are creating the workspace. We will click on delete resource group. Once we click on delete resource group, it will ask us to like reconfirm like what was the resource group that you want to delete. What is the resource group that you want to delete? So I punch that in, and now you can see that there is a container registry right here. Like this, the first one. This was not created when I created the resource group. This was created when I like deployed it to endpoint, because that created a Docker image. So that is the point the container registry comes in. And Workspace will always have a container registry, an application insight service, a storage account, and like the key vault. So all of these resources can, if you click on like the delete now, then it will take some time and it will delete itself. So let me show you how we can delete the resource, like because that is the most important part out of everything we have learned today, because we have to take care of our resources. So what I am doing is I am going into MLSA RG, and I am creating clicking delete resource group. So here I have clicked on delete, and now it is like everything will shut down one by one, and the entire thing will be deleted when everything here is done. So like that was for the demo part. Now if you want to learn more about and everything that we just went over today, you can for sure you can go to the resources that are linked in these slides. You will be getting these slides on GitHub. Just let me put the entire link to these slides over in the chat, so that it is easier for everyone to get those slides. So let me just copy this if I can. Yeah, so I have copied it, and where is my chat window? Here are the slides. Let me just post that. And yeah, that was it from my side. And you can reach out to me on the given socials, and do tag me if you are posting about today's event for sure. Uh, and would love to see that. If you have any questions, you can just write down in the chat, or I'm enabling your uh, permissions for unmuting right now. So if you would like to unmute, you can unmute yourself and start speaking about anything that you want to say. If you have any questions or any queries, let me know. These are my socials. You can also reach out to me on any of these platforms. Uh, and I'll love to know what you thought about this entire webinar. And after you have got what you desired, do fill out this feedback form that I have also sent over on the chat window. So that will help me out a bit in like understanding how was your experience. And all of those people who had registered, and show also those people who have showed up for the uh, entire duration of this webinar, will be getting certificates from the MLSA program. And thank you all for attending, and it was such a nice day talking my heart about this topic to all of you. And if you have any questions, I am still here for a minute or two. You can ping me down in the chat, or just let me know using any emojis if you like the session. Okay, I see some emojis. Uh, okay then. Yeah. Good day, everyone. Have Let me know how it went. You can shoot me an email if you have any doubts regarding this topic, even after this event is done. And let's hope you can use Azure Machine Learning from now on for some of your projects, so that you can quickly get up and running with machine learning without having to write some extensive code for that. And with that, I'll now end up the recording for the session. So, okay. Shugal Tayal has raised their hands. Yes, Shugal, I have allowed you the mic and the camera. You can uh, speak out your. You can speak. I think you can unmute yourself, or like put down your questions if you have any. If you are unable to find out how to unmute, you can like click on the there are three buttons. Like, one is for the video, one is for the middle, is for one is for the audio, and the third one is for share content. You might be able to unmute yourself. If not, you are free to type down in the chat. Okay, I think Shugal might not have any questions at this point. So one thing you can do, Shugal, you can reach out to me on one of these socials. You can take a note of it, or I can send it in the meeting chat right now, or I will send you an email with your certificate, and you can reach out to me there. Uh, but right now, I'll just close out the recording. And yeah, it was a great time with all of you. You have been a great audience, and see you again.